These are solutions to summer 2025 mathematics AS1 module. First thing you do is read the paper, and it says 3 sig figs, and the total for the paper is 100 marks. Question 1. So it says solve the simultaneous equations. I would just give these a name. I just call these equation 1, equation 2, equation 3. And then I like to say what I'm going to eliminate. So I have decided here to eliminate the z. So I'm just going to say eliminate z. So that means from two equations I need to get the same number of z's in each equation, and then I can get rid of them. And if you notice, equation 1 and equation 2 both have one z in them, and the signs of the z's are different. So if you add equation 1 and equation 2, that's going to give you a new equation 4. So adding 1 and 2, 4x plus 5x is 9x, minus plus 3y plus minus 2y is going to be just plus y, and 18 plus 3 is just 21. Okay, I have a wee bit more work to do now for the next one. I'm going to use equation 1 and equation 3. So I need to get the same number of z's in both equations. So I'm going to have to multiply my equation 1 by 3. So notice I do this first. I write this down first before I do anything. And the reason I do this is quite often people will multiply this side by 3 and forget to multiply this by 3. So you do make mistakes in these. So when you're going through, you can find your mistake easier if you have this wee bit of instruction telling you what you have done. Then you can at least know what you're looking to see if you what you're working out is. So left hand side, 3 times 4x is just 12x. 3 times the 3y is going to be 9y. 3 times the minus z is minus 3z, and 3 times 18 would be 54. Then we'll write down, what did I say to use equation 3? Write down equation 3 again. And all these wee steps really help you to not make mistakes if you just write that equation down again. And then if you look at the z's, the signs of the z's are the same this time, same sign, subtract. So we're doing, again, look at what I'm doing first before I do anything. I'm doing my description, and this will give me equation 5. So 12z minus 7z is 5z. 9y minus 4y is going to be 9y plus 4y, which is going to be plus 13y, and then that's going to be 49. And yep, okay, and then it's right there. And then we want to then decide what we're going to eliminate from my equation 4 and 5, and I'm going to eliminate y. So I need to get this number of y's the same. So what I'm going to do is multiply my equation 4 by 13, which would give me 117x plus 13y is equal to, and then the 13 times the 21 is going to be 273. Okay, and now we've got the same signs for the y's. We're going to subtract. So I'm just going to do my top one minus the bottom one. You might have wanted to do it the other way around, entirely up to you. But that would give you minus 112x is equal to minus 224. Then divide across by the minus 112, you'll get your x is equal to 2. I like to put it in a box. And then we'll sub that into equation 4. So instead of x, you're going to write 2. So equation 4 becomes 9 times 2 plus y is equal to 21. 18 plus y equals 21. Y is equal to 21 minus 18. Y works out to be 3. You found 2 of your unknowns. File them back into equation 1. Where's my equation 1? It was 4x. So 4 times 2 plus 3 times y, which is 3, minus z is equal to 18. A little bit of working out, that's going to be 8 plus 9 minus 18 is equal to z. So swap my 18 and my z around. And what did that give me? That's going to give you 17 minus 18. So that's minus 1 equals z, or z is equal to minus 1. Now what I would do, I wouldn't bother writing this down, but I would check in equation 2 or equation 3 to see if your answers are right. I have done that, and they are. Right, transformation question now. It says figure 1 below shows a sketch of the graph of the function y is equal to f of x, and you've got your point, a key point, which is a, which is for 2, and the general shape of your f of x, and it says sketch on the axes the graphs of y is equal to f of x minus 2. Now generally what the rule is, if you've got your thing is inside the bracket, then it's in the horizontal plane and it's awkward. So here minus 2 inside the bracket actually moves it right by 2 units. And this one inside the bracket, it's a reflection horizontally. That's how I think about it, but it really is a reflection in the y-axis, I suppose it is. Okay, so we're going to move this graph. We're going to move this graph 2 to the right. So if you imagine you move that 2 to the right, it's just going to go like this. And that point is now going to be 6, 2. So that's the graph we're going to draw for the first one. So what have I just said? 6, 2. And that's all that we can do. Okay, so that's my, call it A dash. And that was y is equal to f of x minus 2. Now the next one was a reflection horizontally. Let me get rid of this, just do this on the original and then we can see it. So we reflect this horizontally at this point. It's going to reflect over to here. So it's going to reflect 2 minus 4, 2. Have the same general shape. So again, we'll add it in just so for completeness. I just said minus 4, 2. So that's my A dash is minus 4, 2. And there we are. Use a ruler. Don't do it as I say, not as I do. So f of minus x. There we go. Next one, lovely question. Right, this is basically a GCSE further mathematics question. It says find the equation of the normal to the curve given by the equation y is equal to 2x cubed plus 6x squared minus 5x minus 12 at the point x equals minus 2. Okay, first of all, let's do our dy by dx, which is, the nicest way of saying it, is a gradient function. So if you differentiate that thing, you're going to get 6x squared plus 12x minus 5. And a wee word, just say when x equals minus 2, your dy by dx is equal to, that's going to be 6 times minus 2 squared plus 12 times minus 2 minus 5. File that into your calculator, that's going to be, what's that going to be? 24 minus 24 minus 5, just minus 5. There we are. And okay, right. Find the equation of the normal to the curve. Oh, I can see I've made a wee mistake in mine. The normal to the curve, that means what you've got then, the gradient of the tangent is equal to minus 5. That means the gradient of the normal is equal to the negative reciprocal of that, so 1 over 5. So that's what we've got. Right, we also need to find a y value for my curve. So just say when x equals minus 2, y equals, so we're putting minus 2 into the original equation, so 2 times minus 2 cubed plus 6 times minus 2 squared minus 5 times minus 2 minus 12. Okay, so that is going to be, what's that going to be? Minus 16 plus 24 plus 10 minus 12. Use a calculator for this. That's going to be 34 minus 28. Y is just going to be equal to 6. It is indeed. So you've got the point minus 2, 6. Okay, now your normal. The normal is just an equation. It's a straight line. Y equals mx plus c is the nicest way of doing it. You could, some people are taught y minus y1 is equal to m upon x minus x1. Absolutely fine if you want to use that way. I just don't like it at this level. But your normal then, put it in, is y is equal to 1 over 5x plus c. And then put in minus 2, 6. Which means 6 is equal to 1 over 5 times minus 2 plus c. And I'll get rid of all this just so I can see. Oh, here, would have run out of space here. Then that is going to be 6. Obviously, you know an exam not to do this. This is just me to try and keep us on the one thing. So that's going to be 6 is equal to minus 2/5 plus c. And that means 6 and 2/5 is equal to c. So what you've got is y is equal to 1/5 x plus 6 and 2/5. It mentioned to get it in the form ax plus by plus c equals 0, where a and b and c are integers. So what we've got to do here is multiply through by 5 do that on your calculator to make sure you get it right. What's 6 times 5? 6 times 5 is 30, and then 5 times the 2/5 would be 2. So that's just going to be plus 32. And then we would bring it all to one side, and then you're just going to have minus x plus 5y minus 32 equals 0. That should be the answer. That's different than what I've got because I had written down, I had done the tangent, hadn't read the question properly. There we go. Okay, so hopefully that's right. Right, this next one, tricky enough wee question here. You've got to solve this thing. This is, well, it's an index question, but it also turns into a quadratic, believe it or not. So let's have a wee look at it. This thing here could be written as x to the power of 1/3 squared, and then that's 3 times x to the power of 1/3, and then I'll bring that 28 across, minus 28 equals 0. So we're going to let y equal x to the power of 1/3, and then it becomes y squared minus 3y minus 28 equals 0. And then you can do your sum and product or whatever way you want to do it. I've just factorized that to give me y minus 7 upon y plus 4 equals 0. And that means y minus 7 equals 0, or y plus 4 equals 0, which means y is equal to 7 or y is equal to minus 4. Right, they never mentioned y to us. We invented our y really here. So that's x to the power of 1/3 is equal to 7, or x to the power of 1/3 is equal to minus 4. So something to the power of 1/3, what that means, by the way, is the cubed root of xn equals 7. That means x is equal to 7 to the power of 3. That means x is equal to 343. Likewise, the cubed root of x is equal to minus 4. So x is equal to minus 4 cubed. Leave the minus inside the brackets. Minus 4 times minus 4 times minus 4 would be minus 64. Lovely. Okay, what do we got now? It says the shape in figure 2 below shows a triangle PQR joined to a semicircle with diameter PR, and PQ is 5, QR is 11, PQR is 113. Find the area of this shape. Okay, right. We're going to have to find the area of this triangle. We can do that using half AB sine C, but you're also going to have to find this area of the semicircle. So you're going to need, to find the area of a semicircle, you're going to need the radius. So if we find x, that's the diameter, and then we can then divide that by 2 and find the radius, and then you can find the area of a semicircle. I think I will do the area, finding x first. So you find x by the cost rule. And the reason why is you're trying to find the opposite angle, the opposite side, and you've got a side, and its included angle. So that's cost rule territory. The only other way to use the cost rule is if you had all 3 sides and you wanted to find an angle. So if you had that side, you can find the angle. But we're another one where you've got like the angle, we call it the jaws of a crocodile. So you've got the jaws of a crocodile and you're trying to find the other side. Okay, so what did I call that? I call that x. So we're just going to say cost rule. So the cost rule is a squared equals b squared plus c squared minus 2bc cos a. So x squared in this case is 5 squared plus 11 squared minus 2 times 5 times 11 times cos of 113. A little bit of working out, and I have got my x, and I've used, look how many decimal places I've got. My x is 13.747051. There we are. And then we'll find, therefore, the radius, divide that by 2, 6.87350755. And then we'll just say area of the semicircle then. Area of the circle is pi r squared. So it's a semicircle, so it's a half times pi times my r squared, so that's 6.87350755 squared. Using all those values, that's 74.212433902, if I've been able to read that correctly. Okay, right. I'm just going to do this up here, the next bit here, just so we can see our diagram. We want to find the area of this triangle, and we're going to use another wee Formula for triangles, which is area, is a half AB sine C. So much like your cost rule, this is to find the area if you've got a side, and again their included angle, which we have. Happy days. So that's going to be a half times 5 times 11 times sine of 113, and that works out to be, if I've done that correctly, 25.31388, and then we're going to add this to our semicircle, so your total area is 25.31388 plus the 74.1244 will go to the 5 dps for them both, and then that's going to be 99.5 centimeters squared to 3 sig fix. So you can see my accuracy, unless I've messed up not putting in the calculator, I've used more than enough degree of accuracy. Nice page wasted here and here. Don't know what they're doing. Okay, right. Lovely. Okay. And this is a little cast diagram question. First thing you want to do here is divide across by the 2. So cos 3x equals minus root 3 over 2. And my angle was not just x, it was 3x. So, sorry, let's just write there's above. That's what they had. You multiply the x by 3 to give you 3x. 0 by 3 is 0. And 180 by 3 is 540. So you've got to go round. What's that? A time and a half? Okay. First thing you do in your calculator is basic angle. Now listen carefully to what I'm saying here. For your basic angle, you do cos to the minus 1 off root 3 over 2. So you're ignoring the negative, and that gives you a basic angle of 30 degrees. Now the negative comes into play when you do your cast diagram. And cos is negative in here and in here. So that's 30 degrees and 30 degrees. I'm going to do this exactly as I would do it if I was doing this myself. I wouldn't bother labeling all of these bits. I would just leave it here, and I just know when I get to here, that's positive 90. When I get to here, that's positive 180. And then positive 270 back to 360 and so on. Alright, so that's exactly as I would label it in a diagram, and that's fine. So the first angle I come to is around here. The next angle I come to is around here. So that's only within 360. So I'm going to have to go round another time and again. That would take me around to 540. So I've got those 3 angles. So the first one was my 3x was equal to 3x is equal to 150 it's going to be. And then the next one is going to be 30 more than 180, which is 210. And this next one is this 1 plus 360. So if you do that 1 plus 360, 150 plus your 360 just works out to be 510 degrees. Okay, very easy to make mistakes on these, so just be aware of that. So I've got those as my 3 values. Divide by 3 then. So divide by 3. So 150 divided by 3 is just going to be 50. 270 divided by 3 is 70. 510 divided by 3 is 170 degrees. Okay, and there we go. Okay, logs proof. Right, not a proof that I like, but a proof that you really should know. It's a starting bit always gets me, but you really do need to learn this one off. And if like me, there's a bit of it you don't like, you've got to learn this bit. So the bit that I don't like in this proof, that I always need to think about, it's the very start of it. So you let x equal be a to the power of p, and you let your y equal a to the power of q. Okay, well now what that gives you therefore that p is equal to log to the base a of x, and q is equal to log the base a of y, and we'll be using that in a bit. Okay, now if you do your x times your y, that's the same as a to the power of p times a to the power of q. That means xy is the same as, by indices, a to the power of p plus q. Now if you take logs, log the base a of xy is just going to be equal to p plus q. But then that means log the base a of xy is equal to log the base a of x plus log the base a of y. There we are, 6 marks, which an awful lot of people are not going to get because they will not have learned that proof of, unfortunately. Next bit says, hence find the exact solution of the equation. So here, what you must do is you must use what you've done previously. So remember, we've done that log x plus log y is equal to log of xy. That's what we've just done. So this thing then we can rewrite as log the base 3 of x upon x plus 4 is equal to 2. And then by your basic definition of logs, the log of a number to a given base is the power to which the base must be raised to give the number. That means x upon x plus 4 is equal to 3 squared. Multiply out and tidy up, that's x squared plus 4x is equal to 9, which means x squared plus 4x minus 9 equals 0. Ooh, don't think that factorizes. We're going to use our quadratic equation. Xn is equal to minus 4 plus or minus 4 squared minus 4 times my a, which is 1, times my c, which is minus 9, all square rooted, all divided by 2a, which is 2 times 1. Tidy that up, that's minus 4 plus or minus, what's that going to be, 16 plus 36, 16 plus 36, let me just check that, sorry, I done that right, that's next bit. 16 plus 36, 52, square root of 52 is, yep, that is right, sorry, that was 2 root 13 I was getting there, over 2. And then tidy that up, that's just going to be minus 2 plus or minus root 13. And just say it can't be negative. You can't have a log of a negative number. So the only answer is going to be x equals minus 2 plus root 13. Okay, lovely wee binomial question here. It says expand this thing in ascending powers up to x and including the term in x cubed. So you've got 1 minus 2x is equal to, and this thing here, so is going to be, and I'm going to do all of my working out here. I'm going to do 8c0, and then my 2 is to the power of 8, my x is the power of 0. Now the trick for this, and once you get the first term done, this 8 is always going to be the same. These two numbers are always going to add to give the 8, and as this number decreases, this number increases. And likewise, this part here is the same as this one. Okay, so we'll just do it. This number here, sorry, the 0 is the same as that second power. So next one, the 8 always stays the same. We're now 8c1. Still 2 to the power of something, x to the power of something. The 2, the power of the 2 has gone down by 1. The power of the x has gone up by 1. Take a new line. And the next one is going to be 8c and 2. 2 to the power of something, it's gone down. So it's gone down to 6. And my x, and it's gone up. And then 8c3. And then 2 to the power of 5, x cubed. It does go on, but we don't need to worry about it. And that's it. Now, I'm going to assume I've done this wrong. I'm going to assume I've done this right. That's going to be 256 and then plus, and if I can read my, I can't read my own writing. I'm going to have to do this, bear with me. 8c1 times 2 to the power of 7 is, 1024x. The next one I can read, so hopefully it's right. It is 1792x squared. And the last one, which I'm just going to check here, 8c3 times 2 to the power of 5 is 8c3 times 2 to the power of 5. I've got something different, right? So I'm going to check this one here as well. Apologies. 8c2 times 2 to the power of 6. Yep, that one was right. That was 1792. And the next one, 8c3 times 2 to the power of 7. It's not 2 to the power of 7 at all, it's 2 to the power of 5. Okay, right, that's a weirder one. You got the same thing again, 1792, and that's my x cubed term. Apologies. Right, just well check that one. Okay, hopefully the rest of it was right. Now what we're going to do is multiply out. So we multiply these terms, see what we get. So multiply everything by the 1, you'll have 256 plus 1024x plus 1792x squared plus 1792x cubed. And then multiplying by minus 2, you'll have minus 512x. And then that's going to be minus 2048x squared. And then that's going to be minus 3584x cubed. We would also have an x to the power 4 term, but we don't need to worry about it. So we tidy these up. You're going to have all of your numerical terms. First of all, you've only got one. You've got 256. Your x terms then, you've got this one minus this one. So that's just going to work out to be plus 512x. My x squared ones, we have got this. So we've got 1792 minus 2048, which is minus 256 x squared. And then my cubic ones, I've got 1792 minus 3548, which is minus 1792 x cubed. Okay, so that was those last pair for that one. Okay, hopefully that's right. Next one, lovely proof here. Right, what you've got here is a very ugly looking proof, but a very, very nice one. So we're going to work with our right hand side. The only thing you've got at AS level is the following. You've got the sine squared plus cos squared, x is equal to 1, and also you've got the tan x is sine x over cos x. So it's not like we've a lot of proofs to learn. So that's all you've got. But this is a tricky one, right? Our right hand side, on your numerator, you've got sine x. On your denominator, I'm going to take a denominator, a common denominator on my denominator of 1 plus cos x. Now this minus sine squared is already there. We have to multiply this, that 1 becomes, to bottom line gets multiplied by 1 plus cos x, top line also gets multiplied by 1 plus cos x. Okay, now the only thing we can do here is change our sine squared on our top line of our denominator to be 1 minus cos squared. Okay, and then that is sine x, and the bottom line would be, and that's going to be still 1 plus cos x, tidy up the top line, 1 minus 1 is 0, and then you're just going to have cos x plus cos squared x, and then we can factorize that bottom line. So you've still got the 1 plus cos x here, but on the top line you can pull a cos outside a bracket, leaving you 1 plus cos x. Sometimes people like to put a bracket around it and make it a wee bit clearer that that's going. So really what you've got then, that is just, you've just got sine x and it's being divided by cos x over 1, and that's just the same as sine x divided by cos x, which is the same as just tan x. Not an easy proof, but well, I enjoyed it. And next one, it says, figure 3 below shows a solid prism. Its cross-section is formed by joining an isosceles triangle to a rectangle, and the rectangle has a width of 6 meters and a height of y meters. The isosceles triangle has a perpendicular height of 4. The prism has a length x meters and a volume of 120. Okay, no idea. Right, so it says show that y is equal to this thing. So, right, first of all, let's make a start. We'll just say volume is equal to your cross-sectional area times your length. So your cross-sectional area will work this out. So we've got this rectangle first of all. That's easy, that's 6y. Then we've got this triangle. And, oh, it's just half base times height. So half times 6 times 4. That means my cross-sectional area is just 6y plus 12. Now again, volume is equal to cross-sectional area times length. We know it has a volume of 120. So 120 is equal to 6y plus 12 times my length, which was x. So times x, which means 120 over x is equal to 6y plus 12, which means 6y equals 120 over x minus 12, which means y is equal to 120 divided by 6, which is 20 over x minus 2. So you've got a value for your y, and that's what we're looking for. Happy days, we got our 4 marks. It says, hence show that the total surface area of S can be expressed as this thing here. Okay, right. To get this total surface area, you're going to have this rectangular side, which is a slope. You're going to have 2 of those. You're also going to have 2 of these sides, and you're going to have 2 of the ends, just 4 by y, and then is that it? You're also going to have the base as well, which is going to be, if you imagine I shade that in this pink colour, that base shape there, you're going to have that. And what else you're going to have? Oh, you're going to have the 2 triangular ends. So we triangular end there, and 1 on the far side as well. So you've got a lot to do here. Right, we're going to have to look at this triangular end. We know that's isosceles, so we can split that. The height of it is 4. The whole width of it is 6, so that wee bit must be 3. Oh, that works out easy. That's going to be 5 then by Pythagoras. You've got a 3, 4, 5. If you needed to use Pythagoras to find the 5, you don't know your Pythagorean triples, do so. But you've got that. So here, let's just draw a wee diagram of that in our answer bit, please. That's going to be, that was 3, that was 4, so that was 5. Put a wee bit of a circle around that to show you've worked that out. So my surface area is going to be equal to, okay, here, I'll do this up here then, so we can see our surface area. So our surface area, let's do our triangular bits, or no, sorry, I don't know what I'm doing first. I'm doing 2 times 5x. What's my 5x? Where on earth is my 5? Oh, we know that's 5. This must be my slopes then. So I've got 2 times 5x. My slopes are 5x, slopey bits. And then I have 2 times my x, and where is my x? Oh, sorry, my cross-sectional area. Let's be smart about it. Let's be smart about it. We know what the whole cross-sectional area is. We've already worked this out. Sorry, I was going to waste a lot of time there. As being 2y plus 12. Okay, so what I've done so far, I've done my 2 cross-sectional areas, and then I've done my 2 slopey bits. Then I just need to do the side bits then as well. So I've got 2 x's, 2 xy's, sorry. And then I've also got the base, which is going to be 6x. So there we have it. We've it all done. So that was the whole cross-sectional area done. My goodness, would have wasted a lot of time doing it the other way. Okay, so just doing it here just so we can keep this all together. My S is going to be 10x plus 12y plus 24 plus 2xy plus 6x. Tidy up time, and if you tidy it up, you're going to get 16x plus 12y plus 24 plus 2xy. And then remember, we were given this, that y was equal to 20 over x minus 2. So that's going to be 16x plus 12 times 20 over x minus 2 plus 24 plus 2x times 20 over x minus 2. And then we'll multiply that out, tidy up at 16x. That's going to be 240 over x minus 24 plus 24 plus, and then that's going to be just 40 minus 4x. It's a mess, but it can be tidied up. 16x minus 4x is 12x. And then I've still got my plus 240 over x, and my 24 and my minus 24 cancel. So plus 40, that's what we have. Lovely. Okay, so that was done already. Now it says, hence find the value of x for which s is minimum. So let's write my s again. It was 12x plus 240 over x. Write that as an index form, then plus 40. We want this thing to be minimum. So you're going to do the old differentiation. So ds by dx. And differentiate that, you're going to get 12 minus 240 x to the minus 2. And then to find a minimum, you put ds by dx equal to 0. So that 0 is equal to 12 minus 240 x to the minus 2. Or 240 over x squared is equal to 12, sorry. And then 240 is equal to 12x squared. Divide across by the 12. 240 divided by 12 is equal to x squared. And that's going to be just 20 is equal to x squared, which means x is equal to plus or minus the square root of 20. X is equal to root 20. That's the exact value for it. Hence find the value of x for which s is minimum. You've got to prove it's minimum. So you've got to differentiate this thing up here. So we've got to find d2s by dx squared. I'll just do this first and then bring it in, zoom in, sorry. So that's going to be 480 x to minus 3. And then you just say when x equals root of 20, your d2s by dx squared equals 480 times root of 20 to minus 3. That's going to be greater than 0. Therefore, minimum s happens when x is equal to root of 20. Lovely. A big blank page here. Right, what's going on here in this one? We've got a wee integration question, is it? It says, figure 4 below shows a sketch of the graphs of the curve and a straight line. The equation of the curve is given by y is equal to a squared minus x squared, where a is a positive integer. A positive constant, sorry. The curve and a straight line meet at the x-axis and the y-axis. And find the curve and straight line meet at the x-axis and y-axis. Find in terms of a the area of the shaded region. Okay, right. This point here. Right. First of all, our line. Let's see. We need to find where they meet. Well, we know this x value anyway. We need to know this x value. We know this, but we don't need to know our the x point here, the second one. So we need to find that. Right, our curve, our line, first of all, what's the general equation of a straight line? It's y equals mx plus c. And the curve is y is equal to a squared minus x squared. So. Well, the curve meets whenever you want to put x equal to 0. So if you put x equal to 0, that'll give you this point. So we'll put that into the curve. So that means y just equals a squared. Oh, there we go. All right, so that means that gives you 0 a squared. So first of all, I've got this point up here is 0 a squared. And also then we want to put on the curve, put y equals 0. And you're going to have 0 then is equal to a squared minus x squared. That's the difference of two squares. That could be a minus x upon a plus x, which means x equals a, or x equals minus a. And so basically that has told you this point here is minus a and this point here is plus a. But the key one is that is the point A0. That's where it crosses. Okay. Right, now what we have to do is just find the area under the curve. So we're going to find the area under the curve. So we're going to find this whole area using integration. We don't need to find the equation of a straight line at all. We can just find that area, and then you can find the area of this triangle. And then that will allow us to find the shaded area. So we'll do the area under the curve first. I'm just going to do that up here. So area, get rid of a bit of marking here. Area under curve is going to be equal to the integral between 0 and a of just the curve, which is a squared minus y squared. If you integrate that, a squared minus x squared, would have been a different kettle of fish. A squared minus x squared, and if you integrate that, square brackets, you're going to get a squared x, because a squared is just a constant. So if you integrate it 7, for example, you get 7x. So integrate a squared, you get a squared x, and minus x cubed over 3. Remember, when you integrate, raise the power by 1, divide by the new power. Now just fire the a into it. That's just going to give you a squared times a. That's going to give you a cubed minus a cubed over 3. Then minus, and then that's just going to be a squared times 0. And then minus 0 cubed over 3. So it's just 0. So it just gives you the area under the curve is a cubed minus a cubed over 3. You could write that as 2a cubed over 3, or 2/3 a cubed. So that's what we've got so far. The area of the triangle, and you can see that triangle, the height of that triangle, do this in red here, the height of that triangle is a squared. The base of that triangle is just a. So area of the triangle is a half times base times height. That's a half times the base, which is a, times the height, which is a squared. So that's just going to be a cubed over 2. So the shaded area is those two things subtracted. So the shaded is just equal to 2a cubed over 3 minus a cubed over 2. To do that on your calculator, folks, just forget about the a cubed and just do 2/3 minus a half and see what you get. And 2/3 minus a half is going to be just 1/6, or a cubed over 6, and that's going to be units squared. Tricky enough for your question there. Confused me at the start. Okay, right, question I got, folks. You can see there, I was going to start doing a whole pile of stuff with y equals mx plus c, and then I just sort of changed my mind and I thought that's not going to get me anywhere, and then just put my values of, when I cross the x-axis, put y equal to 0, cross the y-axis, put x equals 0, and then it got me my endpoints in terms of a. Okay, last question. Is this the last question? It is indeed. A straight line is given by the equation x plus y equals p, where p is constant. The straight line is a tangent to the curve y squared equals 2p minus 3xy. Find the value of p. Okay, right, let's write down what we've got. We've got our line is y equals, making y the subject, minus x plus p. And the curve is y squared is equal to 2p minus 3xy. Right, all I'm going to do is substitute my line into my curve. So subbing my line into my curve. So my curve is going to become, everywhere I see my y, I'm going to replace it with minus x plus p. Okay, and then we're going to multiply it out. To do this out without making mistakes, good idea to just write that out the longer way. The minus x minus p is minus x minus p squared is minus x minus p upon minus x minus p. Multiply it out, you'll have x squared. And then that's going to be, that's going to be Oh, is it plus P? Sorry, that's a plus P. I see my mistake there. Sorry, that should be a plus P. That should be a plus P. Just be very careful. There's the sort of mistakes good mathematicians make, so just be very careful in those sorts of things. Then when you do that out, minus x times minus x is x squared minus x times p is minus px. P times minus x is minus px, and p times p is p squared, and that's 2p. And then minus 3 times minus x is plus 3x, then minus 3p. Bring it all to one side and put it equal to 0. Have I even read the question here? I can't remember. The straight line is a tangent to the curve, so we're going to be using the discriminant here. It's going to be a b squared minus 4ac type question. Bring it all to one side, you'll have x squared, and then that's going to be minus 2px. What else have we got? Minus 3x, and then you're going to have your p squared, and then p squared. Oh, sorry folks, I had another wee mistake there. Look at that. That was a 3x. Right. Apologies. Got the last question. I'm messing this up. Right. Let's do that again. Sorry, that's going to be multiplied out. That's going to be minus x plus p upon minus x plus p. It's equal to 2p minus, and if we'll just do this one out here, that's going to be plus 3x squared, and then that's going to be minus 3px. Apologies, I think I missed an x there. And then on the left hand side, multiplied out, you're going to have x squared minus 2px plus p squared is equal to 2p plus 3x squared minus 3px. We'll bring it all to the right hand side. You'll have 2x squared, and then my minus 3p, and then plus 2p minus 3px, and then plus 2px. That will be minus px. And then you're also numerically, you're going to have your 2p minus p squared. Okay, I said there, this is about tangent, so we're going to be using b squared minus 4ac, and we're going to be investigating this thing, or if it's a tangent, it's going to be equal to 0. But your b is the minus p, your a is a 2, so just write down capital A equals 2, your b equals minus p, and your c, this is the awkward one, c is this whole thing, so 2p minus p squared. Okay, so then we want to say tangent, so b squared minus 4ac equals 0, and I would write that in. They probably want you to demonstrate that you understand if it's a tangent, your b squared minus 4ac, or what's called your discriminant, is going to be 0, and then we'll just go with that. So the b was minus p squared, and then the 4 then is, sorry, the a is going to be 2, and the c is 2p minus p squared equals 0. Tidy this mess up, that's going to be p squared, and then that's going to be minus 8 times that, it's going to be minus 16p, and minus 8 times that is going to be plus 8p squared is equal to 0, or 9p squared minus 16p equals 0, which means p upon 9p minus 16 equals 0, which means p is equal to 0, or p is equal to 16 over 9. And I think that's the only one that's going to work. And it's, yes, it says in the question, p is not equal to 0. So your answer, your last thing, apologies for any mistakes, is 16 over 9, which is 1 7/9. And that is it. Just check there. Yep, that's the end of the paper. And that is it. Tough enough wee paper.